All right, let me get my slides going. There we go. Oh, and this thing is right in the middle of my screen. Neat. Oh, that's cool. Cool. All right, so reduxing from 3 UI libraries to 1. Kind of wrote this over the weekend. Been a little busy, but I will give it my best. So no fancy animations, and I suck at art, so no awesome graphics other than one slide that you'll find later. If you didn't get enough information out of this talk, like Sabrina said, I will be here for quite a while afterward. I'm happy to answer any questions and talk about this at length. I like this stuff. It's cool. What's up? Is that better? Hold on. How about now? Better? Okay. I don't want to get feedback. Yeah, so if that's not enough, we can talk later. Who's this dude? Senior front engineer at Tune. I've been here since the end of April, about 6 months. Used to be a C++ developer, worked on a video editor for a while. Grew to hate C++, JavaScript is much better. Sorry if that angers anybody. Part of my job role is to make really bad jokes for the team. I have a quota of at least 1 groan a day, and I think I'm keeping up with that. So what's this talk going to be about? I was kind of hoping to center this around just our experience with integrating React and Redux into an existing Angular app. We're mixing the two. I know that sounds fun. Ultimately, we want our app to be fully React. Other products at our company are using it, as their entire view layer. If you came to the last meetup at Tune, you might have seen Patrick and Dave talk about this huge repo of components that we're sharing at Tune. We want to use those in our app. We don't want to keep building our own. But there's not really any good way for us to move all of this at once. It would probably be 6+ months to move the entire app over to React. That's not really acceptable from a product standpoint. So we're looking for ways to sort of jam React and Redux into this app piece by piece. So as we refactor views or add features, we can start moving things over to React. So why Redux? There's plenty of Flux libraries out there. What's so special about this one, I guess? Some of us have experience with a few different libraries. I personally used Reflux before. It was okay. I liked how simple it was. We've tried a handful of other Flux libraries. None of them were really blowing us away in terms of I guess features or ease of use, etc. Redux looked kind of neat. If any of you have seen Danny Ramov's talk on this, he does some really cool stuff, time travel included. So we decided to go for it. We are going to do a little bit on what Redux is. My apologies if you already know everything about Redux. I didn't really want to assume that level of knowledge. I know it's a React meetup, but it's kind of a new library. Worst case scenario, you can closely watch what I'm saying and then come up later and rub it in my face that I said something wrong. That's totally fine if you want to do that. I'll take that well. So what exactly is Redux? It's Flux, it's not Flux. It's probably better if you don't think of it as Flux, but it has some of the the same ideas that are found in Flux. So there is one-way data flow. The difference between this and a lot of traditional Flux implementations, or at least Reflux if you're looking at it that way, you have a single store holding all of your state as a tree, instead of multiple stores that are each responsible for a particular domain, and you have to sort of subscribe to multiple stores and match things together and figure things out like that. Another big thing, state in Redux is feeding back. I'll do this. Okay. State in Redux is treated as read-only, and mutations are done via actions. That might be a little bit in common with other Flux implementations. Computing new state based on an action, that's done by pure functions that should not have side effects. And really, there are a lot of functional programming paradigms to be found in Redux. That's kind of its big thing, is it steals a lot from functional programming. But kind of a cool thing is that Redux isn't really tied to React. It's general purpose, or it's touted as being so. You can use it with other view layers if you want. And we're actually using it with both React and Angular in the same app, which we'll get to in a little bit. The graphic I promised you, isn't it pretty? You might notice that this arrow isn't like the rest of them. I'm sorry. So we'll start from the store and work our way around. The store in Redux is very minimal. It's just going to be holding the current state tree and then exposing some functionality to subscribe to it and to mutate it. Computing the new state is done by reducers, and like we said, those are going to be pure functions. We generally kind of combine all of the reducers for each domain that you care about into one big function, and that function's job is, here's the current state and an action, give me the new state. That's all the reducer's going to do. And then your UI components, they can be React, they don't have to be. Those will receive that whole state tree, turn it into whatever it needs, and React, it's going to be props that are passed from parents to children via React Redux, which we'll get to. And then those components can also dispatch actions to mutate the state. And that's going to be your user interaction or loading data from APIs and things like that. Your store will apply those actions by running them through the reducer, this big reducer function, and then you get your next state. So it's just this big state machine that moves from one state to the next. Oh, I skipped something a little bit. We'll get to it later, but actions in Redux are plain JavaScript objects. That is kind of important and kind of not important. They want you to always do plain objects, but in practice, you probably won't ever do plain objects. So things that I kind of thought were important about Redux. This is all kind of familiar. If you've used other Flux implementations, a lot of these concepts are the same. That's why they say it's Flux, but it's not. Redux advocates enforcing immutability on the state. It's a very important concept. If you have a mutable state, at each state transition, you can use the pure render mixin or pure render-like functionality to keep from re-rendering parts of the UI that don't need to change, right? That's very easy to do if all of your state is immutable. The root reducer is a composition of reducers that handle specific domains, so that means that only the parts of the data that need to be updated get updated, and you have full control over how granular that can be. Big emphasis on plain objects and serializable objects, and one of the cool things you get, or a few of the cool things you get, are basically out-of-the-box support for server-side if you want to do that type of thing, if you're into server-side React. Hot loading, which I can't really demo, but Danny Ramov's talk has a great demo of it, and a couple of other really cool things, and this is all assuming you follow the rules in Redux and do it the way they kind of suggested. In general, though, and this is maybe an opinion, I guess, the basics are pretty simple. There's not a whole lot going on with Redux, and sort of similar to functional programming, it's your job to take those basic pieces and compose them how you see fit to get your complex functionality, whatever works best for you and your application. All right, so let's go through the moving parts. I'm trying to get out of Keynote. Yep, okay, I gotta do this, turn around. So this is one of the example applications from the Redux library. It's very simple, but we're gonna kind of go through the individual pieces that make up this thing to get an idea for what it takes to build an application with Redux. So it's a counter. You can increment it, array, you can decrement it, array. If it's odd, you can increment it. And then you can set a timeout and increment it in like half a second or a second.
Hey, Randy?
Yes.
Can you blow that up, Dave?
There we go. Plus, minus, increment if odd, increment it after like 2 seconds. Super useful application. All right. So going through the pieces, we're going to start with reducers. And just as a note, all of these, can you read that? That's probably really small, isn't it? Son of a... All right.
It's okay.
Okay. I am recording it, so this will all be available later, and I will publish the slides. All the examples are in ES6 syntax. Some of you are probably really familiar with it. Some of you are like, what is going on? That's okay. It is neat, though. If you haven't looked into using it, you should. So this is a reducer that manages the domain of the value of that counter. That's its only job, is to maintain the current value of that counter and figure out what it is whenever we apply an action. So it's a function that accepts the current state as its first argument and an action as its second argument, and its job is to return the next state for this domain. Simple. Couple notes: if the action that it receives is not something that affects this particular domain, so it's like logout action or navigate action or some other action that has nothing to do with the counter, this reducer is going to ignore that and just return the current state. And assuming that's an immutable object, that's basically a no-op on affecting your current state, right? And the other thing is, if the incoming state is undefined, which will be the case the first time we run this reducer, it's this reducer's job to return the initial state. And that's 0 in this case, which might not be obvious if you're not familiar with default argument syntax. So state being equal to 0 up there means we'll default initialize that to 0 in case it's passed in as undefined. All right, so that was one domains reducer, and I said before that in general we want this big mass reducer that's the whole, converts the whole state from one state to the next. To do that, we use a helper function from Redux called combine reducers. Combine reducer's job is to map reducer functions into their various domains. So what combine reducers will do is accept an object that you pass to it and give you back a function that whenever it is called, will call each of those sub-reducers that we pass in the object. It will feed them their individual piece of state, their domain, and then let them do their calculation, return it, and then map that domain to the output object. So it's just doing exactly what it says, combining reducers into one return value. And you can use this pattern recursively, so you build a whole tree of reducers. That can be as fine or coarse-grained as you want. If you want one function that can just computes all of your state every single time, go for it. You're welcome to do that. If you want every possible prop that could exist anywhere to be its own reducer, you're also welcome to do that. It might be a performance concern if you do it that way, but it's really up to you to decide what's the right logical separation for your data and for your domains. All right. Man, that is really small, sorry. After reducers, we look at actions. And typically in Redux, we don't really talk directly about actions. We'll talk about action creators. Action creators are going to be a function where you call it and it gives you back an action that needs to be dispatched against the current state. We said before that in Redux, proper actions are always going to be plain objects. So in this case, the increment function returns a single object that just has a type in it that says what action we're performing. Decrement does the same thing. They're both going to be different actions. You don't have to call it type. You can make that property whatever you want. If you're following Flux standard actions or some other convention, then there are some rules. So we use Flux standard actions in our application, so that property has to be called type. And there's some special stuff that happens when you use that. And whatever data you want to go along with the action can be in there as well. So it doesn't have to just be a type. It can also be some sort of payload object that's got a whole bunch of information about this action. And as long as it's a plain JavaScript object, Redux is perfectly happy with it. It'll pass it along to your reducers and state change occurs. Take note of the string constants for the action types. That's important in Redux. All actions have to have unique names across the entire application, right? Because you're going to ultimately be doing, at the most basic version, a huge switch statement over this, right? So you need to be able to compare those against each other to tell which action you're running. An easy way to do it is to use namespaces followed by action names. We have a quick little helper function that does that for us. You just feed it a namespace and a name, it generates a string constant for you. Pretty simple. The other thing to notice is that we export those constants, and that's so that the reducers can import them and things stay in sync. If we ever need to change the name of that action for some reason, like we would care, we never actually use it in a hard-coded form, but if we wanted to, then we're exporting it and importing it so everybody stays in sync. ES6 is really neat. Okay, and then the other big piece is the store. And the store is probably, I don't know, in my opinion, might be the simplest part of this because you rarely really interact with the store. You don't do much with it. Setting up is, I put insanely simple in here. That's probably an exaggeration, but it is pretty simple. So Redux exposes a create store function. You hand it the root reducer, so all of your reducers combined into one big function, and the initial state that you want, which can be an empty object or undefined. If you don't care if all the reducers are doing all their own initial state, then it doesn't matter what you pass in there, right? It's going to run the root reducer once to generate the initial state by passing undefined to everything, and then it stores that. And now it's got your state, and it gives you back a store object with a couple of methods on it. Dispatch allows you to apply actions to your store, or to your state, sorry. Get state gives you a reference to the current state, and you can dive in and see everything in that object. And there's a subscribe method that I'm not using in the example that lets you subscribe to changes. That gets used by React Redux and various other libraries to help you connect to the Redux store, and do things when the state is modified. It's kind of the the meat of the thing, but you really don't end up using it directly a lot. You might have noticed, if you are close enough to read this really tiny text, that I glossed over a couple things. Redux does have a concept of middleware, and you can get by without knowing anything about it, but it's where things kind of get fun. The concept is a lot like Express, if you've ever used Express, where middleware get injected into the store, and anytime you run, or anytime you dispatch an action, each middleware in the chain gets to look at the action on the way through. It can modify the action, it can return a new action, it can cancel the whole process and do something entirely differently if it wants. They use the next syntax the way Express does, so each middleware has a next function. When it's ready to push it along to the next middleware, it just calls next with the action. There you go. In this code, we're using the Thunk middleware. Thunk is probably the best word in computer science. It is, in my opinion, probably the most useful and necessary piece of middleware. You could probably get by just using Thunk and do a full Redux application and never have to touch any other middleware. But what it does for you is kind of neat. So we had said that Redux requires all the actions to be plain objects, right? That's not super useful if you need to do, multiple actions or asynchronous work like loading data. So, any of the things that probably have to happen in a real application, right? So Thunk actually lets you pass a function instead. That's kind of cool. You can dispatch a function as your action. And what Thunk will do is intercept that. It's not going to call next and pass it along because Redux will freak out and yell at you in the console. But it will instead call that function and pass dispatch and get state into it. So that lets you write action creators that return a function that will then dispatch multiple actions if it wants to, or do some asynchronous work and then dispatch actions, or whatever you could want to do. Now you have a function that's logic, whatever logic you want. So the two examples in the counter thing we were looking at would be the increment if odd and increment async. And we'll go through a little bit. So increment if odd returns a function that accepts dispatch and gets state. And really all the logic we need to increment if odd is we need to look at the current state and see what the counter value is. If it's odd, then we dispatch an action to increment it. If it's not odd, then we're done. We don't have to care. We're not going to dispatch any actions. The important part being that we have access to the state through the getState function. You could make the argument that increment if odd could accept a parameter that is the current value, and in this case, the React component does have access to that value and could pass it in. But there's all sorts of other things you could need access to, like the current user's ID. That's not going to be available to, probably not going to be available to the the component that's dispatching this action. So getting at the current state is an important concept. Increment async is, all it needs to do is wait for a little bit and then dispatch an action. So the benefit we're getting here is the Thunk middleware will call our function, give us dispatch. We can do whatever asynchronous work we want. In this case, set timeout for a second. And then after that set timeout, we're free to dispatch an action. And it's all these references to dispatch are all pointing at the same functions. There's nothing wrong with delaying this and doing it later. We can dispatch 3 things in a row if we want. The fact that it processes all the state synchronously anyway means you're going to dispatch it, the action will run, the reducers will compute the state, and then returns back up the stack. And you can dispatch the next one, right? So this is the most important pattern in my mind for building a real application in Redux, is being able to use Thunk to do asynchronous actions. You could do it without Thunk. I'm not going to get into that because it's a little ugly, but this is kind of neat. It's kind of nice. Okay, so basics more or less of Redux. Everybody getting it? Feeling good? It's okay if you're not. I didn't get it the first time either. It's all kind of simple in my mind. It's easy to follow once you kind of go through it a little bit. But like a lot of other things that are really simple, you can add a lot of magic if you want to. You don't have to accept the really verbose, simple way that Redux proposes. There's already tons of middleware available. There's ones that convert. If a promise comes through, they'll wait on the promise, and then when it resolves, they'll dispatch the result for you. You can also write your own middleware, which is kind of neat. I've seen quite a few examples of writing a custom API middleware. So the idea being that you dispatch an action, it's got a special property, like API data or something, a key that we care about, and then you have a middleware that intercepts that, sees that that property exists, and then reads the values off of there to get things like what endpoint you want, what data you need to pass, what query strings, etc. Calls the endpoint for you, because you're using REST APIs, right? So all the calls are the same, right? And then, when that call comes back, it can dispatch the result for you. And you write that code once in a middleware, and then everybody's just dispatching these plain objects that say, I want to make an API call to here with these parameters, and then dispatch the result, whatever that happens to be. That's a pretty cool concept. The Redux examples, I'll kind of use these gigantic switch statements that make my eyes bleed. You don't have to do it that way. There's nothing wrong with doing it that way. It just kind of feels weird to me. But there's very simple solutions to make that easier. We use a library called Redux Actions that lets you just define an object that maps action names to functions. That just looks better to me. And it's pretty simple, and I'm okay. I can keep using Redux without feeling bad. One thing to keep in mind, though, is the more magic that you add to this. So you could go at it full force and say, I'm just going to grab all the middleware I can find that everybody uses and says is great. I'm going to pull in all these libraries and everything. And then you're going to hand it to your teammate, and they're going to go, what the hell is going on? Like, I can't even begin to follow the code here, and like where all these actions are going, and I dispatched a thing with one property, and it made 5 API calls, and I don't understand what's going on. Like, that's a real concern, right? So if you're going to take this on, you're best to start simply, like, do the switch statement if you have to for a little while. Get everybody ramped up on it. Get everybody figuring out how Redux works, how actions get dispatched, and all that, and then start adding all the magic once everybody's familiar with it, because you can get yourself into a bad situation if you don't. The other thing that kind of bit me a little bit, they say it a lot in the docs, and it's an assumption that you're going to use immutable data. They don't enforce that. There's nothing in Redux that says you have to use immutable data, or like no code that's going to yell at you for not doing it. Your stuff will just have really weird behavior and not do what you expect it to. It's kind of up to you to do it. And I do like that once I realized that was something I was supposed to do, because it doesn't force you into a library. So immutable.js, they mention that a lot in the docs. I don't really like immutable.js. Like, we used it for a little while, and then trying to get used to the API of how you get things and set things in that felt really clunky. It doesn't work with Lodash at all. And we use Lodash everywhere, and I've really grown to love using Lodash. So we switched to seamless immutable instead. And Redux doesn't care as long as we're following immutable data structures. Works just great. So that's kind of cool. All right, so let's look up the UI part of this little counter example, and lots more tiny text. So I didn't write this. I'm just claiming it right away. This is the UI from that example. A handful of buttons rendered in a p tag. Hooray! So this component accepts as props the counter value, and then all of the functions that are needed to modify that counter value, and then just wires them up like you might do in any React component. One thing to notice here is this component has no notion of Redux. It's not importing Redux. It's not doing anything with Redux. It doesn't care about Redux. It's just a pure React component that's going to take props and render itself. That's an explicit choice. React Redux operates on the concept of smart versus dumb components. This may not be a React Redux thing. I think this is a separate article, but it's important to use these things together. So a smart component would be one that knows about your data store. It knows how to connect itself to your data store, how to subscribe to changes to your data store, how to get things out, and its job is to convert your data from your data store into props and feed that to the child components. Dumb components are pure React. They don't care about your data store. They're not going to know about it. They're not going to connect to it. They're just going to accept props and do their thing. And generally, what you want to do, or what's advised, what we've been using works great, is you're going to have the container component, the topmost view, if you want to put it that way, will be a smart component. So you might take a particular route in your application and say, the view that's rendered for this route That's my smart component. It's hooked up to Redux. It grabs all of the stuff I could possibly need in this particular page, and it will feed pieces of it to all the child components that it's rendering. Seems kind of weird, but trust me, it works a lot better than everybody connecting to the store. I've tried that, and it sucks. All right, so in this particular example, the container is actually not a great example of a container because it's not a component on its own. It's just wrapping a component, creating a higher order component if you want to get fancy. But it does show us how React Redux works and how we get connected to it. So there are some details on how you embed React Redux in an application involving wrapping things in a top component similar to how you would do like React Router or other libraries like that. Not really the important part, so I left it out, but it's in the documentation. The important piece is at the bottom. It's the connect function that we're importing. So connect, it accepts two arguments. The first one's going to be a function that maps state, Redux state, into a props object. And it's going to receive the entire state from Redux, not just the domain. It'll be the whole thing, right? And then the second argument is going to be a function that does sort of the same thing, but for action creators. So it's going to bind all of the action creators that we need from Redux and turn them into plain functions we can call as props and have them dispatch call the action creators and dispatch actions for us. We're using a helper function to do that part, bind action creators. That's from Redux, and it's more or less just like doing partial function application so that you don't have to constantly call dispatch to dispatch your actions. You actually can call dispatch to dispatch your actions if you want to. You can have that passed along as a prop and do all your dispatching manually if you want to do it that way. This is kind of a little bit cleaner. More magic, I guess, if you want to put it in the magic category. Connect gives us back a higher order component that will merge all of the generated props and functions into the props object and then render the component that it's wrapped around. Pretty common pattern in the React world. So yeah, like I said, in this example, the component that we're returning, it's just a wrapped version of our view, and we're moving all of the Redux logic into this component. But typically, all of the cases where I've done this have been actual full-on view components, so they're rendering the five or six child elements and passing each of them the props that they need. And its only real job, other than a basic render function, is to do all of the props and Redux work. And then connect does a little bit of internal magic to actually subscribe to the Redux store. So whenever a state is actually modified, it will run that state to prop mapping function again. And then if that props object coming out has changed, I believe, it will re-render the component for you. A little fuzzy on those details. I think you have to do that part yourself. If you want it to be efficient, you have to do a little extra work. But the point being, React Redux does the subscription re-rendering part for you. All right, so all of that was a lead up to how we're using React and Redux, or attempting to use React Redux in kind of a unique scenario maybe. I'm calling our application the monster jokingly. It's not really as bad as it sounds. It's kind of evolved through years of technology changes, and keeping up in a startup environment occasionally means some technical debt. Get it out the door before we go under, right? It's far from the worst thing I've ever seen, but I still like to call it the monster. Our app actually lends itself pretty well to piecemeal React migration. We have a small amount of global state that we use to keep track of things like user session, feature flags, various top-level things that are common to all views. But for the most part, each route is an isolated page. It's got its own controller. It's going to do CRUD type operations, and it uses some Angular services to do like model and API work. So we kind of have two versions of refactoring in this application. We can either replace an entire route so that the whole view that we render in its place is a React view instead of an Angular one. Or we can do sort of a partial replacement where we still let the Angular controller and template do the main rendering of the page, but we sort of embed a React view inside of it and mix them together. That's kind of arguably the more interesting case. So we're gonna go with that. Okay, so we have two Angular directives that we've written, and apologies for the Angular diversion. It's not really important if you know how Angular works. I'm just going to go through, kind of the pieces that have helped us do this. The first Angular directive, we call it React element, I think, and the whole point is that we want to render a React component inside of an Angular view. That's its job, right? So it's going to accept which React component we want. It will accept props to pass to that React component through attributes on the element, and then it's going to use the internal or the global top level. There it is, React API to do rendering onto the element that the directive is attached to. We don't use that one a whole lot. Managing the data binding between Angular and then pushing it into props in React gets kind of messy. It's really easy to generate a lot of bugs with that, or just trying to keep that straight is a little bit of a nightmare. Angular directives in general are a nightmare. Adding this into the mix doesn't make it easy. The second Angular directive that we use is called Redux View, and so this is that whole view embedding case, and this does basically the same thing. You're going to pass it which Redux view you want, but then internally it's going to do all the work we need to set up React Redux and wrap the right components around that, and then use the top level React API to render our view or our container component into a particular element that's been generated by Angular. The important piece being we don't pass props through that directive. Since it's already hooked up to React Redux, it's directly connected to the Redux store. So there's literally no interaction between the Angular elements on that page or the controller or anything and this Redux view. It's doing its own work with the Redux store. Okay. And we kind of found that, as you might expect, it's a lot easier to keep all of the state and actions and things like that in Redux instead of and find a way to sync them into the Angular scope than it is to go the other way. Keep everything in Angular and find a way to expose those to React components. Angular is kind of picky about how you do things. All right, so in light of that, how do we keep this state and these actions synced up with Angular? ng-redux is the solution that we're using. That's pretty slick. Does all the magic we need to combine Angular and React and Redux. So if you remember earlier, I kind of said that Redux isn't tied to React, and that's kind of what makes this possible, right? Since Redux doesn't really care if it's in React, it's just a very simple pattern of you want to modify some things, you run a function, and then we'll call you when your data changes, and your data is just this big plain object. It's pretty easy to write a library around that to connect that into Angular. So ng-redux works a lot like React Redux in that it exposes a connect function that can map the current state and action creators into a particular scope object in Angular. And then it's going to do all of the subscribing for you so that it pushes updates every time the state changes. It also does all of the Angular digest stuff for us. If you've ever used Angular, making sure that you're in a digest loop and things get updated. It's got its own cycle and everything. It sucks. You could say that, right? It's React Meetup. Angular sucks. All right. For the partial refactoring case that we're talking about, where we're embedding a couple of React components into a page, this helps us a lot because we can let all those components use the state, and then if there's any shared state that the Angular components need, then we just synchronize that with ng-redux, and we're all set. All right. So remember when I said you didn't need to know Angular? Ignore like lines 3 through 5 and like down here, right? Okay, and you're all set. This is an example of an Angular controller that's using ng-redux to connect the state to the scope. There's a little bit of setup involved with getting ng-redux connected to your store, and that's back when we were talking about creating a store, and passing in the root reducer and all that. You do one extra step there to make sure ng-redux can subscribe to it and watch it. It's not represented here. But like the React Redux case, we're going to define a function, which is the middle part here, that maps the current state to, it was props in the React world. In this case, it's mapping the state to scope. It's still just an object transformation function. You feed in one object and you get out another object. ng-redux .connect is going to accept that function, that mapping function, and then, like the other case, it's going to accept all the actions that we want to expose in the scope. Excuse me. And then it's going to return a function that we need to call once, and we feed it the scope object that we want to attach all of this to. So more fun functional stuff where you call a function that gives you a function, and you call that on another function, and functions everywhere. So once we've called that, we've got everything connected to our scope object. And then we're now subscribed to state updates. So every time the state updates in Redux, ng-connect is going to fire that mapping function again, figure out what, let it generate its thing, and then it'll merge that into scope for us. And it does all of that in a digest cycle, so Angular will update the UI and do all of its data binding correctly. When we call connect, we get back an unsubscribe function. This is kind of a little bit of an Angular detail. So if you haven't used Angular, whenever you unload a particular view, the scope and the controller assigned to that view get destroyed. So the unsubscribe function is meant to be used when the scope goes away. You should unsubscribe from the Redux updates, so you're not trying to merge changes into an object that's been destroyed. That's all that's about. All right, so a template. This is, kind of one way we could do the Angular stuff. So the idea here is we're going to render in Angular the basic setup of, here's my counter, here's the counter value, and here's a button that will increment the counter. So that's your H1, your span, your button up there. And then below that, we'll just render the same thing in Redux. Why not? Like have the Angular version and the React version together on the same page. So those Angular elements, they're going to use their normal Angular controller, their normal data binding, and their normal template. And then the Redux U element is going to render that smart React container inside. It'll be hooked up to the store. And both of them are bound through React Redux and ng-Redux. They're bound to the exact same store. So if you click increment 1, they'll both get the update, and they should both render it. That's kind of cool to see that in action. In hindsight, I should have probably written an example for that so you guys can see it in action, but well, wrote it on Saturday. What do you want? So there are kind of some happy path cases where this pattern works really well. By the way, that was it. Like that's literally all we've had to do to get ng-Redux into Angular and get these things talking together. It's been a lot easier than I expected it to. But yeah, there's some happy path cases where this works really well. So it's really easy to embed things like modals and toasts onto a page because they're just going to render some content over top of everything. It doesn't matter where they are in the document flow or anything like that. So you can just have your normal Angular template, put your Redux view at the bottom, and it'll render its React stuff. And then if it needs to show a modal in the middle of the screen, it'll render it with position, absolute, or fixed, or whatever. You're all set. It's also easy to replace an entire section of a page. So again, if you're doing block level display stuff, you can do your Angular stuff first, and then put a Redux view in there and let it render all of its stuff wherever it needs to, and then under that do more Angular if you want to. And then of course, replacing an entire route, like we talked about, that's super easy to do. The Angular template just becomes Redux view. So there's no controller. You just tell Angular to mount an element, and then tell React to render into it, and then Angular doesn't care or have to do anything anymore. Question?
Was this using the Angular router the entire time until everything was converted over?
Did you read my slides already?
I'm sorry.
No, that's okay. Yes, it is using the Angular router. Actually, I think that's on this slide somewhere. Wow. I have like whole paragraphs of speaker notes here. This is not how you do a presentation. Okay, so where it kind of doesn't work, mixing React components into random parts of the page. So that's that first Angular directive we talked about that puts a React element, like a single button somewhere, and then we have to manually connect props to it and keep it updated with the scope. That sucks. And it's mostly because those components you're going to render, those are dumb components. They don't get to know about Redux, so they don't get to subscribe on their own way to all the state updates and interact with Redux outside of Angular. Likewise, trying to move little pieces of controller or model logic into Redux and leaving other bits of it still in Angular gets kind of messy because you might be updating certain things using Redux actions and then syncing them, and then you realize that, okay, well, when I sync that into scope, I used to, in Angular, set these other 3 variables along with it, so now I have to subscribe to that, and in my mapping function, I have to go set them all, and I have side effects, basically in my reducers, and that's not correct according to Redux. You get into a lot of those situations where if you've got a lot of logic that depends on each other, moving part of it into Redux can actually make it more complicated. So it's kind of better to pick isolated pieces that can be moved or move them wholesale at once if you can. Same thing goes for global state. Any reducers or actions that need that state should probably have that state stored in Redux. Gets complicated to try and read it out of Angular when you need it. It could change randomly, between 2 lines of code. If you did something asynchronous, I guess. It might mean doing a huge refactoring step to move all of your global state into Redux, but it's probably worth that effort unless you really have a ton of global state, in which case I don't know what to tell you. We haven't really had to deal with a ton of global state yet. We have a few things that we moved over, a few things I'm a little worried about, but for the most part, we'll probably just move it all at once. It might take a week or two.
When you are moving that global state to Redux, are you then using ng-redux to feed that data back into parts of the Angular application?
Right, so the question is, when you move that global state into Redux, you then use ng-redux to synchronize that back into Angular, and yes, that is how you do it. You can, if you have things like on root scope, it's very easy at application bootstrap to just hook up ng-redux to say, okay, whenever the state updates, let's push stuff into root scope, and it just works. Like, it'll stay synchronized the whole time.
Have you found any situations where you're actually kind of duplicating any of the like global data store between Angular and Redux?
Okay, so the question is, have we had any cases where we're duplicating global store between Angular and Redux?
Or not necessarily global, but...
Or any state in general, sure. So when I first started working on the couple of views we were moving, that did happen because I was a little naive about how this ng-redux stuff works. In general, it doesn't though, because you usually are going to move it into ng-redux or into the Redux store, and then it's really easy to just have ng-redux set up to push it back into the scope if you need it there. There's no reason not to do it that way. Well, there's no reason I can think of. Another question?
Yeah, for the first bullet, if you've got two areas of the page that aren't really connected that you want random React components into, is that just two smart components to run them, or what else gets messy about that?
So the question was, if you have random two separated sections of the page that want to use Redux and could be smart components, is that doable, and what gets messy about it? Is that close enough? Is your question? Okay. So you could do it that way. I was more talking about if you're inside, I guess, so for reference, like the way our app works is global header, nav bar, and then body. And body is typically its own container. Every time you switch routes, the whole body gets replaced. So inside of that body, if you're mixing and matching React components, those are each going to be dumb components. If you wanted to, you could make individual pieces of your app that maybe something that sticks around a long time, like the header itself, could be a smart component that's rendered. That would be just fine. It's more if you find yourself in a situation where you want to render these really small React components that really probably shouldn't be smart components, like a button or a form, like generic things. Those get a little messy because you don't want to connect those to Redux if you can help it. Okay, there will be plenty of time for questions. I'm the only speaker. So things that I liked about this whole React Redux Angular nonsense. Overall, the transition to React Redux has been very helpful to us. Other than the ramp up time, I totally made that too much magic mistake and had to give several presentations to my team about all this stuff that I screwed up and made their lives harder, and felt bad about it. Redux is kind of a lot easier to follow conceptually, at least it is for me, than Angular. Definitely true. And it's been a little easier for us to debug. There's lots of really helpful libraries, one of which will spit every action that you dispatch out into the console, and it shows you the state before the action with its payload, and the state after the action. That's awesome. There's also, if you've seen Dan Abramoff's talk, he's got this really cool time travel debugger thing that shows you all of your actions in a panel, and you can click on one and your whole app rewinds to that state. That's pretty awesome. We can't use that because Angular, right? Angular sucks. So our React workflow has kind of been a lot faster, at least for me it's been faster than I've typically been able to iterate with Angular. Some of that might be because it's a legacy Angular app. There's just lots of connected pieces. But just getting things done feels better. React has an easier to follow model, in general. That's why we're all here. Redux lends itself really well to unit testing. Since everything's going to be these, small pure functions, even the action creators, the most that they're going to do is return you a function that wants you to pass two functions to it. That's pretty easy to mock those with any spy library. So testing any of the logic that needs to go on in these things has been pretty simple. You can get into if you need to mock, APIs or models and things like that. That's about the hardest thing you'll have to do. Some unit testing in Angular gets really messy because of, okay, now I have to mock HTTP, now I have to mock set timeout, now I have to mock all these internal Angular services that want to do all this weird stuff that I have to figure out. And, since it's React, it's just the Vue library. You're free to do all the other stuff the way you want, and since they're all individual pieces you'll have to import anyway, mocking them is very easy. Replacing things piece by piece keeps us on the good side of the product team. Nobody wants to have the product discussion, but if you say you want to replace all of your app code and it's going to take you 3-4 months to do it, you're not really going to get that buy-in unless you have a really cool boss or one that doesn't understand how money is made. So that's cool that we can do this piece by piece, right? And then, due to how Redux works, you can easily follow this pattern with other UI frameworks, right? So we're mixing and matching React and Angular. I don't think there's any reason you couldn't do this with Ember or pick your other UI library. The fact that it's so minimal and just all a bunch of functional stuff means you could, whatever approach might work best, you could probably apply that to other ones. We have another product team that's going to be looking into doing this with Ember at some point. I'm hoping that goes well. It sounds like it could, right? Matt's excited. It's working. All right. So then the thumbs down slide. Less things, right? I hope. All right, so thumbs down, it's simple, right? You can shoot yourself in the foot pretty easily. I kind of like to call it backbone syndrome. If you've ever used Backbone, it's the same problem. It's up to you to kind of abstract away all the simplicity in the way that works best for your app. So it's really easy for you to abstract that so much to make your life easier for you that your whole team can't learn it or that you eventually have trouble debugging it. You have to be really careful with the magic because it's such a simple thing, right? A lot of the really elegant patterns in our code base, or in some of the solutions that we've looked at, lean on a lot of ES6 features, ES 2015, whatever you want to call it, to make this stuff really cool and simple and easy to follow. You could probably do all of this without ES6. You really wouldn't want to. It would suck, I think. But you could. I think you could. There's that bullet point. We're still on Angular router. So we can't use a lot of the cool stuff, hot loading, time travel debugging, storing our router state in Redux. That's really cool. I'm doing that in a side project, and it's kind of cool to have all of your router parameters available in your state tree. That's neat. Other than that, I couldn't think of a whole lot of other things that were really bugging me about this solution. I actually thoroughly enjoyed getting React and Redux into our code base. So that's my list of bad stuff. And maybe you guys have bad stuff about it. We should talk about that. Nobody pointed out that I said 3 UI frameworks at the beginning of this talk, or in the title of this talk. I did say 3. Sort of attendance bait, I'm sorry. It is true, we do use 3 UI frameworks, but I realized as I was writing the talk that the 3rd UI framework just became a case, another case of the existing problem. So our 3rd UI framework is, I'm going to try to get this right, embedding legacy PHP-generated pages that use jQuery inside of our Angular views and then proxying a bunch of stuff through Angular services by exposing them as global objects. It's not fun, right? I, to date, have not had to touch that code. Thank you, Kevin and Dave. But the idea is since they're just these, it's again one route is rendered like this, we'll just take that whole route and just rewrite the whole thing in React Redux. We're not going to bother trying to mix Redux and React into a jQuery page like that. That's a nightmare. I don't want to do that. So yes, there are 3, but it's really just 2 concepts. And yeah, if this wasn't enough, I can talk about this all night. Really, I like this stuff. I'll be around to answer questions. Like I said, we're going to be in the back room if you want to talk to us. Every presentation must have a quote. So I quoted Sabrina in saying that we're hiring, my team specifically. So if you're interested in talking to us about jobs, please come talk to us. You don't have to come back there if you want to talk about jobs. I'll just talk about React stuff. That's cool too. And with that, thank you. And I suppose questions, if we want to do questions like this, or you can come talk to me here. Any immediate questions? Cool. I think Sabrina wanted to talk again.
Oh, stop. Stop, Snagit.